There's a new disaster recovery feature in town for Server 2016 Data Center Edition, and it's called Storage Replica. It supports a number of scenarios for zero data loss replication across racks, buildings, cities, and even countries. In this nugget, we're going to cover those scenarios, the many features that Storage Replica provides, and we'll jump into the virtual Nugget Lab and learn how to configure one of those scenarios, server-to-server replication. Let's do it. Prior to Server 2016, our only native solution for disaster recovery in Windows was DFSR, Distributed File System Replication, which was often used with DFS namespaces, but could also be used as a low-budget standalone file replication solution. The problem with DFSR is it wasn't really designed for disaster recovery. It was designed to provide remote sites access to files over low bandwidth, high latency connections. Your typical branch office scenarios. So large workloads could take days before they're truly in sync with those remote locations. Add to that the fact that DFSR is file-based replications means files in use aren't replicated. So the end result is a high potential for data loss if disaster were to occur. Storage Replica, on the other hand, was designed from the ground up specifically for disaster recovery and disaster preparedness. By the way, DR, or disaster recovery, is a plan we put in place to ensure that our applications still function, our data is still available, our business still operates when catastrophe occurs. Like Mother Nature decides that there should be an earthquake right now underneath our data center, resulting in a non-operational infrastructure. You'll often hear terms such as RPO and RTO associated with disaster recovery. RPO stands for Recovery Point Objective. It's essentially how much data loss can we endure. RTO is Recovery Time Objective. How long can our business operate without a specific application? Disaster preparedness, on the other hand, is a plan for preemptively moving our applications and workloads to another location prior to catastrophe occurring. Like a hurricane. A hurricane's coming our way. How prepared are we to shift this workload to another location? Storage Replica has scenarios to support both disaster recovery and disaster preparedness. It is volume-based, block-level replication. And this one right here is a big deal because unlike DFSR, files can be in use. We're below the file down at the block level. So files can be in use all day long and replication will still occur. It also supports both asynchronous and synchronous replication. Now, synchronous replication is designed for high bandwidth, low latency networks. So between racks, between servers, between buildings in a city, and it guarantees zero data loss. And that's because data must be written to both volumes in a replication group before the I/O is marked as complete. Now, because of that, and depending on your network speed, synchronous replication can slow down your applications because that write needs to occur in multiple locations. But you will use this for business critical applications where you cannot endure any data loss. Asynchronous replication, on the other hand, does not wait for that I/O to complete at both locations. It writes it at the source and replicates it over to the destination without waiting for any acknowledgement. So this is good for those low bandwidth, high latency connections and gives us a disaster recovery solution across geographically separated areas, like across cities or countries. Another great feature is that it is storage hardware agnostic. Depending on your scenario, you can use locally attached storage, direct attached storage like JBODs, network attached storage, and even storage spaces. And remember, this is not file-based replication, it's volume-based replication. Now, Storage Replica supports three primary scenarios: server-to-server, cluster-to-cluster, and stretch cluster. There's also a fourth one, server-to-self, which I'll mention here in a bit. Let's start with server-to-server. Let's say that we have building one. In building one, we have server one, and we have a volume that we want protected. So if building one ever loses power, we can quickly get up and running over here in building two because we have a copy of that data over here on server 2. So server-to-server replication supports both asynchronous and synchronous replication. The default is synchronous, and it's the only scenario that supports local storage as well as directly attached storage and storage spaces. So we would set up a partnership between these two volumes, and you would actually need two volumes on each machine, one for the log and one for the replica. So once we set up this partnership, as data is written at the source, it's replicated over to the destination. And if something were to ever happen here in building one, we could manually fail over here to building two. Server to server only supports manual failover. So this is the scenario you'll use when you need disaster recovery at the machine level. And this should also replace DFSR for those that are using DFSR as a disaster recovery solution. Next up, we have cluster-to-cluster replication. Now, we use failover clustering to provide our applications with high availability. We stand up machines, put our applications on them, and they all access shared storage. And we've got lots of nuggets coming up on failover clustering. But this allows us to add some disaster recovery to our highly available clusters. So again, let's say that we have a cluster over here in the East region, and we've also got a cluster over here in the West region hosting our highly available application and all pointing to shared storage. We can set up a replication partnership. It also supports synchronous and asynchronous replication. We specify our source, specify our destination, and now we have replication occurring. By the way, your destinations and all of these are inaccessible. Those volumes are offline, unmounted, purely used for disaster recovery. But what will happen here is, again, if East goes down, we can manually fail over to our West region cluster. And keep in mind, cluster also only supports manual failover. Finally, we have a stretch cluster. Now, this is a single cluster that spans geographical boundaries, right? So this isn't two separate clusters in each location. It's one big cluster where each location has access to its own shared storage. Now, a lot of this works the same. We're still going to set up a replication partnership between the shared storage at each location. It still supports asynchronous and synchronous replication, and we're still going to set up that source and that destination and watch replication occur. The big difference, because we're dealing with a single cluster, is it supports automatic failover. It's the only scenario that supports it. And this all works because of a new failover clustering feature in Server 2016 known as site awareness, where we can group machines in a cluster based on their physical location, which, among other things, ensures that if a node at one location dies, it'll fail over to another node in the same location. And if all nodes in that location dies, it'll fail over to the nodes in the other location. Now, that fourth scenario I mentioned earlier is known as server to self. This is where you'll want to replicate a volume on a machine to itself. This will require a minimum of 4 volumes. You'll need one for the source, one for the destination, and then a log for each one. With that, let's jump into the Virtual Nugget Lab and learn how to configure Storage Replica in a server-to-server configuration. We have a 3-machine lab to work with here. FS1NUG is going to act as our source machine. So we have a volume that we want to replicate over to our destination machine, FS2NUG. We also have a domain controller here. You must have a forest in order to work with Storage Replica. So let's go ahead and start here by logging in to FS1NUG. I'll just paste the password in there and log in. Let's start by launching File Explorer and taking a look at the volumes that we're going to be working with. Hit this PC on the left, and notice that we have 2 volumes here. We have an L for our log and an R, which contains the data that we want to replicate over to FS2NUG. The big requirement here is your volumes must be of the same size. So your replica volumes must be the same size, and your log volumes must be the same size. And if we flip over here to FS2NUG real quick and just verify that, go ahead and log in as the domain administrator. And from the desktop, launch File Explorer. Hit this PC, and look at that. We have a replica volume here, the same exact size, and our log volume, the same size as our log volume over on FS1NUG. So let's do all this over on FS1NUG. I'm going to head back over there. And let's start by going right into the C drive, into the Nugget Lab directory. We're going to do all this through PowerShell here. Right-click on pscommands.ps1 and toss that right in to the ISE. The first thing we need to do is install the storage replica feature on both machines that are going to be involved in the replication partnership. So we're going to run an invoke command here pointing at both our local machine and our FS2NUG machine, so we can do this all in one shot. So we'll install Storage Replica, which will give us access to the feature itself, as well as a good majority of the commandlets you'll be using to create your partnerships and monitor replication and manage it. But we're also going to include the file server role service here. And the reason that we need to do this is to get access to this commandlet right here, test SR topology. This will run just a couple of tests here to ensure that our topology meets the requirements for Storage Replica. And if you're not going to do any sort of tests or you've already done it, you do not need to install this second feature. We're also going to include the management tool so we get access to all these other PowerShell commandlets, and this feature will require a restart once installation completes, so we'll just pass that flag right in there. All right, so place your cursor on line 3 there and run selection, and this will install it simultaneously on both machines, include the management tools, and reboot. So when your machines come back up, relog into FS1NUG and relaunch the script into the ISE. Now we're ready to run a test SR topology. This will run a test between our source and destination machine to ensure that our volumes line up, to ensure that it has enough memory and enough CPU to support this feature. So we'll run this, pass in our source machine name here as FS1NUG, our local machine. There's our source volume, the R volume, our source log volume, the L volume, and then we specify our destination machine parameters as well. We can specify how long this runs. It's going to generate a report. We're going to store it here, and we're also going to say ignore the performance tests. So this will just run the initial test to ensure that our volumes will support Storage Replica. So I'm going to highlight all this here and hit execute. So my test is done. I'm going to head back into File Explorer, into the C drive, into the Nugget Lab directory, and there is the report. If we open this up, it's going to give us just a really nice quick overview here of how many tests it ran, if we have any errors or warnings that were generated. None. Looks like all of our tests were successful. You can see the details down here, and you can also drill into each one. So really nice, quick, easy command that'll save you time just to ensure that your replication partners meet all of the requirements for storage replica. Let's head back into the ISC. So now we're ready to actually create the partnership, and we can use the new SR partnership commandlet to do so. Specify your source computer name, your source replication group name, volume name, log name, and we do that for the destination as well. And this is all it takes. It's very, very simple to configure storage replica for all three scenarios, but this will create it on both sides, and we're done. Now all the data we put inside of our R volume will get replicated over to the R volume over on FS2NUG. And you can see it only took a couple of seconds there to complete. Now at any time we can monitor replication status a couple of ways. We've got the get SR group commandlet, and if we take a look at the replicas property on here, we can see some pretty good information, such as number of bytes remaining. So if there's current replication going on, you'll see the bytes here. We can also see our replication mode, synchronous, and our status, continuously replicating. So everything looks good here. And by the way, you can change your replication mode to asynchronous using the set SR partnership commandlet. You'll need to pass in the source and destination computer name as well as the replication group name, and then you can set that replication mode. We can also monitor the event logs. In fact, if we run a get win event, pass in the provider name of Microsoft Windows Storage Replica, this will show us all of the logs. Now over here in our source machine, our volume is accessible. If we head down to the R volume, check it out. We can start adding stuff inside of here. In fact, let's head back to PowerShell here and let's just add some data in here. We'll add a couple of text files and we'll add just a fake file here that's about 1 gig in size. So I'm going to run all of those. That'll create all those files. And now we should actually see it here in the file system. So those are currently getting replicated over to FS2NUG. In fact, if we head over to FS2NUG and log in once again, from the desktop, let's launch File Explorer, hit this PC on the left, and there is our destination volume. Notice that it's inaccessible. Yeah, it's completely unmounted and only available to our source replication volume. So the only reason we would ever need to use this is if our source machine failed and we need to use this for disaster recovery. We could bring this back online. I'll show you how we can reverse replication so we can actually see the data inside of here as well. Let's head back over to FS1NUG. From here, let's head back into the ISC. And now let's reverse that replication. And we can again run a set SR partnership here, pass in the new source computer name as FS2NUG, and our source RG name FS2RG. Our destination is now going to be our local FS1NUG machine, and we also pass in our destination RG name. So I'm going to go ahead and run that line, and that's going to switch replication. Of course, it's going to prompt us here, are you sure you want to do this? I'll say yes to all. And now what will happen is if we head down to File Explorer here on this machine, hit this PC, now the R volume on this local machine is inaccessible. And if we head back over to FS2NUG, look at this, now it's available. And if we head into here, we should see those files that we created previously. There they are. So now we could add more files into here, reverse replication again, and watch that whole cycle continue. I almost feel like this should be more difficult than it is, but it's really not. It's a great feature and extremely easy to use. Let's head back over to FS1. Let me show you how to tear all this stuff down. So back into the ISE here, we can remove it with a remove SR partnership. So this will blow it away right here. We'll choose yes to all. And if we head back down here, we can also clean up by getting rid of our replication groups. There it is. That'll get rid of them on both machines here. We'll say yes to all. And now we're back to where we were. We'll have 2 volumes completely accessible on both machines. Only now over on our destination machine, we'll also have the same data. Check it out. So here's our source machine. There it is. Replication occurred. We got that zip file that we just created. And if we head back over to FS2NUG, R should be available here as well with all that data still on it. In this TBT Nugget, we learned how to configure storage replica and saw that we finally have a true disaster recovery feature built into Windows Server, and it's awesome. I hope this has been informative for you, and I'd like to thank you for viewing.